In this video, I'm going to be quickly going through the correct answers on the CFE practice quiz for units 5 through 8. So for the first question, make sure you identify that there are two different conditions being given to us, and we need to use both of these to identify which quadrant our triangle will be drawn in. So sine is negative in either the third or fourth quadrant, and cosine is positive only in the first and fourth. So the one that matches both conditions is the fourth quadrant. That's why I drew a triangle going down and right. You have to use both of these to make sure you have it down to a single correct quadrant location. And then I used the SOHCAHTOA rules to say that sine is equal to opposite over hypotenuse. So on my triangle, I filled in those two sides. And then I found the other side, since this is a right triangle, by using the Pythagorean theorem. Once you know all three sides of the triangle, remember theta is always going to be the angle touching the origin of your x and y axis. Then I was just able to use the SOHCAHTOA rules to go through and say cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then the cosecant, secant, and cotangent functions, these are just the reciprocals. So cosecant is the reciprocal of sine, so you're flipping the sine fraction upside down, but you may or may not have to rationalize. This let you leave it with the radical on the bottom, but on the exam I expect it to be more likely that they have you rationalize those answers instead. The second question has given us the sine value, and then they've also told us which quadrants we're dealing with. So we're somewhere on the left-hand side of the unit circle between pi over 2 and 3 pi over 2. And then they mentioned that they want us to use the Pythagorean identities specifically to solve for cosine. So instead of trying to draw a triangle out of this, we'll only get our exact answer if we use the Pythagorean identity, sine squared plus cosine squared equals 1. Well, since we know that what sine of theta equals, I just did that number squared plus cosine squared equals 1. And then I subtracted that decimal from both sides of the equation. And then to get this from cosine squared to cosine, I took the square to both sides of the equation. Now don't forget that that actually creates a positive and a negative answer. But in this case, we specifically end up needing to use the negative version because they told us to pick an angle between pi over 2 and 3 pi over 2. If we had picked the positive answer, then that would have been going to the right-hand side of the unit circle. So that would not have worked with this condition of the angle being on the left-hand side. Here we have a triangle described, and they mentioned two different angles of depression. So remember, the angle of depression is describing a horizontal line coming out, and then the angle between the diagonal line with that. So one angle of depression. Now the second one, if I did this in a different color, there's a second angle of depression being described. So then they're asking us to compare it to this angle of depression, and they say that the difference between those is 30. So that's how we knew to draw a triangle with 30 degrees in between the two diagonal lines that we drew. So that's the difference between the two angles of depression. They also gave us two of the lengths of rope. So in the diagram, they showed us a 440 and 375. Now do note that this is not a right triangle, so you can't use anything like the Pythagorean theorem or SOHCAHTOA rules that only works for right triangles. So instead, we had to use our law of sines or law of cosines. Now in this case, we can't use law of sines because we don't have an angle side pair. I have this angle, but I don't have side A across it. I have this side, but not the angle across it, and I have this side, but not the angle across it. So I don't have any of the angle side pairs, which is why we need to use law of cosines in this case. That formula is on the reference sheet, so then I just plugged in the given numbers and I solved for the A value. Make sure you remember to take the square root at the very end because what you've solved, what the equation is set up as is A squared, not just A. So you do need to take the square root, but we wouldn't use a negative length in this case. So you don't need to worry about the plus or minus for a distance. Now here they have the diagram drawn for us, but they had not filled in the numbers, so I needed to look at the information given, and I'll show you where each of the value goes in the triangle instead. So it says that the sailor spots the rescue plane at a 52-degree angle of elevation. So again, there's a horizontal line coming out and a diagonal line from the sailor, and the angle of elevation is the one in between that diagonal and horizontal line. Then there's a second angle of elevation. So from the man lost out at sea, it says he has a 21-degree angle of elevation. So a horizontal line coming out of that, a diagonal line going up since it's elevation, and then the angle in between is the 21. Now using those two angles, I subtracted them from 180 to find the third angle in the triangle. So make sure you always remember to find the third angle when you know two in a triangle. Next, they told us that the distance between the sailor and the civilian, so this is the horizontal distance, the ones along the base of the triangle, is a length of 200. Well, after filling in that information, I can see that I still don't have a right triangle, so Pythagorean theorem and SOHCAHTOA are still out of the question, but I do have an angle side pair this time. So this time I was able to use law of sines to solve for the missing value. They specifically wanted the distance from the civilian lost at sea to the plane, so I know that I want to use the sine of 52 over this unknown length, and then I set it equal to the angle side pair I do have, sine of 107 over 200. So you would just cross multiply this, which I showed here in the next step, and then divide by the sine of 107 degrees. Here we are given an isosceles triangle, which if you don't remember just means that two of the sides are equal, which also means that the angles opposite those sides would be equal as well, but we don't need the angles in this case. And then they told us the length of those two equal sides. They said that it's 14 for both of them. And then they said that at the vertex where those two meet, they said that there is an angle measure of 30 degrees. So I've drawn the diagram here for reference. They're not asking us to solve for missing sides and angles in this case. They want the area. Since this is not a right triangle, we can't use the more standard 1/2 base times height. Instead, there's another formula for the area of a triangle on your reference sheet. And the only thing you really have to be careful about this is you shouldn't be using any of the angle side pairs like we do with law of sines. So it's two of the sides, and then it's the angle that is not across from either of those. So the formula is 1/2 times the side times sine of the angle that's not across from either of those sides. It doesn't really matter if they're labeled as A, B, or C. You just need to make sure you use all three different variables, A, B, and C. Sum and difference formulas are also on the reference sheet. The way you use these is you pick two angles using numbers that we evaluated from the unit circle. So there are other combinations I could have made. I just said to myself, well, 45 and 30 are two of the easiest angles to work with, and they add up to 75. So the first step is to pick two numbers that add or subtract to the given number, and then you just follow the formula. It's not just sine of this and sine of this multiplied together. Make sure you use the reference sheet for this. So it's sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. And then you evaluate each of those four trig functions separately. So sine of 45 degrees, cosine of 30 degrees, cosine of 45, and sine of 30. Next, I multiplied the fractions together. So I have square root of 2 times square root of 3 is square root of 6. And then the bottom, 2 times 2 is 4. Same thing on the right-hand side, so square root of 2 times 1 over 2 times 2. Since I'm adding fractions, they do have a common denominator. I just recognize that this is the same as the answer I wrote here. They just combine them into one fraction instead. You cannot combine square root of 6 plus square root of 2 in any other way. They stay separate like that. Here we're asked to use the sum and difference formulas again, but this time we don't have specific numbers to plug in and evaluate. They gave us a variable, and then they gave us one angle measurement to evaluate with. So again, I just used the reference sheet to recognize that the formula says for cosine of an angle plus an angle, it's cosine of the first one, cosine of the second one, minus sine of the first one, sine of the second one. Now I can't evaluate the ones that have thetas in there because we don't know what theta represents. But the ones I can evaluate, like cosine of 4 pi over 3, I went ahead and computed those two values. Then if you're multiplying this out, multiplying negative 1/2 times cosine of theta, and then doing this negative root 3 over 2 times sine of theta, I wrote these as fractions instead with a common denominator of 2. So on the top, you have negative cosine of theta, and in the numerator of this part of the fraction, you have a negative times a negative, so positive square root of 3 sine of theta. And then they left the answer in that form. They could have split it up as two different fractions, but again, they went ahead and combined them into one fraction with a common denominator. Remember that if you were given a bearing, you should not be plugging that number into your calculator. Instead, you need to convert it to the math form angle instead. So you can just do 90 minus the bearing. In this case, 90 minus 40 was 50, so that was perfect. That was easy to work with. If I had gotten a negative number, I would have added 360 to it just because we generally like to use our answers between 0 and 360 degrees instead. But in this case, I didn't need to add 360. I got a positive answer. Next, to find the component form of a vector, you just do the magnitude of the vector and then cosine of the angle and magnitude of the vector sine of the angle. That's what makes your x and your y components. We're not adding these two numbers. There's a comma separating them. So this is the horizontal piece and this is the vertical piece. So next, making sure my calculator was in degree mode, I just multiplied out the 600 cosine of 50 and the 600 sine of 50. Here's another question where we were given bearings. So I did 90 minus the first angle. I got a negative number this time, so I just added 360 to make it 185 instead. And then there was a second bearing given. So again, I repeated that process, 90 minus the bearing, added 360 because I didn't want a negative number. Now in this one, we have two different forces. On the last one, we just had the velocity of the plane, but this time I'm going to have a vector for the plane and a vector for the wind. So the magnitude of the plane, 420, times cosine of the angle and sine of the angle. And then for the wind, it has its own vector. This one has a magnitude of 30, so 30 times cosine of the 240 and 30 times sine of 240. So this is the vector for the wind. Now we're just going to add, since we have two forces acting on each other, we're just going to add the x components and add the y components. So I would type this into the calculator and hit plus this expression, and then same thing for the y is that expression plus that expression. If they ask you for the actual speed and the direction angles or the bearings or anything like that, the actual speed comes from doing the square root of the x component squared and the y component squared. This is basically just the Pythagorean theorem. It's saying the diagonal squared equals a squared plus b squared, but they took the square to both sides of the equation. So once you have your combined vector, I squared those numbers, added them together. That gave me the actual combined speed with both the wind and the plane being combined. For the angle that the plane is flying at, you do tangent inverse of y over x. So remember, tangent is y over x, but now we're going backwards. We're trying to figure out the angle, so we're doing tangent inverse of the y and the x values. So when I typed this in, I got 8.22 degrees, but don't forget that there are always two answers on the unit circle. The calculator gave me this angle, but I also need to remember that there's a second angle 180 degrees away. And then out of those two possibilities, we have to pick which one's correct. Since my vector was going left and down, because it has a negative x value and a negative y value, I don't want 8 degrees, because that would be going right and up. I instead want the 180 plus version, because that one's going left and down. Now, this one wasn't super clear to me the way it was phrased, whether they wanted the math angle or whether they wanted us to convert it back to a bearing. From my experience, they generally do want you to go back to a bearing, but the way this was phrased, it sounded like they wanted the 188. I don't think they would have both answers on there without being very clear about which one they want for the multiple choice options. So to convert it back, it's the same thing we did earlier. You do 90 minus the angle you got, so 90 minus 188. But since that was a negative number, I added 360 degrees to it. We just don't like having that negative answer, so add 360 to make it a positive coterminal version instead. So this question has given us two different vectors. We have vector 1 and vector 2, and then they've defined a scalar or a constant. It's basically the same thing in terms of vectors. So what they want us to compute is multiplying that 6 by the first vector, and then they want us to add the second vector to it. So I distributed the 6 through the first vector, so 6 times negative 3 and 6 times 6. And then when you're adding two vectors together, you just add the x components and the y components separately. So negative 18 plus 4 and the 36 plus negative 8. Here again, we have a vector and a scalar being multiplied by it. So we just need to distribute the 9 through both components of the vector. So 9 times 5, 9 times negative 5. And then when they ask you for the magnitude of the vector, that's just like what we were doing with the plane earlier, where you're doing the Pythagorean theorem. So it's the square root of the x component squared plus the y component squared. So I added those together, and then I broke this down by hand, but you can do this in a calculator too, of course. So I got that this is 45 root 2. And then when they asked what direction is it going in, well, multiplying by a positive scalar does not change the direction. What you do have to be careful about is if they do like a negative number being distributed through, then that would change the signs on these x and y values, so it would flip which direction they were going in. But since this new vector is still going right and down, and this one was going right and down, we did not get a change in direction. That would have only happened for a negative number being distributed through. Here we have a diagram with two different vectors being drawn on it. So for the first one, we're just using this 80-degree angle, and it has a length or a magnitude of 8. So I did 8 times cosine of 80 and 8 times sine of 80 to get the component form of that first vector. For the second vector, we have an angle going all the way around at 325 degrees, and then this one has a magnitude of 7. So I did 7 times cosine of the angle, 7 times sine of the angle, and then to add these two vectors together as if these were like two forces acting on an object, same way that we do with the plane and the wind, for example. We add the x components and we add the y components, and that gave me a new vector. So to find the magnitude of this vector, Pythagorean theorem basically, so it's the square root of the x component squared plus the y component squared. So that gave me the length of the combined vectors together. So this first one had a length of 8, the second one had a length of 7. My new combined vector has a length very close in length of 8.1. For the angle that it's going at, this is where we do tangent inverse of y over x. So you can find the angle by doing tangent inverse of the y component and the x component divided together. Remember that there are always two answers to these, but in this case, we wanted one that was going right and up. So I did want the angle that was going right and up as well. I didn't need to add 180 degrees to it in this case. Here we've been asked to just add or subtract some vectors, but they've given us uglier numbers to work with because we do have some fractions in here. So they said to do u2 minus u1. So here's u2, and then I subtracted u1. You're still only affecting the x components and the y components separately. So I was doing 5 minus 1/3, in which case you do need a common denominator for that. So you might want to think of this as 15 over 3. And then since we have double negatives, we're subtracting a negative. It's actually the same as adding 1/3 instead. And then I had 1/2 minus 7, but we might want to think of that as 14 over 2 for common denominator purposes. So 1/2 minus 14 over 2 is negative 13 over 2. Here they had a vector drawn for us. So the first thing I did to identify the vector in component form was I just measured how far was it going to the right and how far was it going up. So this is why we use the Pythagorean theorem, and it's why we use some of our SOHCAHTOA rules for solving vectors. It's because we're actually making a triangle out of them by breaking it into the horizontal and vertical pieces. So this vector was going right 2 and up 3. So my component form was right 2 and up 3 for the x and the y values. For the magnitude of the vector, this is the Pythagorean theorem. We're trying to find the length of that diagonal line when they ask you for the magnitude, or if they say like modulus, any of those kinds of terms. Then to find that, it's just the square root of the x component squared and the y component squared coming from the Pythagorean theorem. For what angle is this vector being drawn at? This is where we can do tangent inverse of y over x. So taking my x and y values from the component form, make sure you remember that there is a second answer in your calculator, but we wanted an answer that was going right and up, both according to the diagram and according to our component form. So again, I did not need to add 180 to the answer that my calculator gave me on typing this in. Here we have the polar or trig form of a complex number. Now to convert it back to a rectangular, this is actually as simple as just distributing. So you would do 3 times cosine of 210, which you can type into your calculator, or you can do this from the numbers you know on the unit circle. So that should have given you approximately negative 2.6. And then 3 times sine of 210. Remember, we're not doing anything with the I, we're just going to have an I on that second part of the number. That's why these could not be added together. They were not like terms. So 3 times sine of 210, and it's going to be that number I. To go backwards from your x and your y value to the polar and trig form that we just saw in the last question, there are some formulas on the reference sheet that tell you that r is equal to the square root of x squared plus y squared. So again, this is our Pythagorean theorem being applied here. So if you take the x and the y components, square them and add them together, that gives you the r value. So for the polar form of a complex number, it's r comma theta. So just look for what r equals and what theta equals on your reference sheet. Now the reference sheet says tangent of theta equals y over x, but we're taking tangent inverse of both sides to solve for theta in this case. So tangent inverse of y over x gives you an answer in the calculator. Again, check whether you need to add 180 degrees to it. In this case, we don't, because we're going right and up, and 68 degrees is an angle going right and up. If you added 180, you ended up going in the opposite direction. Here we've been asked to perform a division operation. Now, one of the things that's important is you can't have radicals on the bottom, and remember, I does count as a radical. So if you have something with square roots in the bottom or i's in the bottom, you need to multiply the numerator and the denominator by the conjugate of the denominator. So 5 plus 2i, but I have to multiply that same thing on top and bottom. And then I was just foiling this out. So 3 times 5, 3 times 2i, I times 5, and I times 2i squared. On the bottom, since I have a number times its conjugate, you can just do the first and the last part of the FOIL if you want to save a couple steps there. So 5 times 5 and negative 2i times 2i. Don't forget that I squared is equal to negative 1. So when I see 2i squared here, this actually is the same as negative 2. And when I see negative 4i squared, this is actually the same as plus 4. So by replacing the I squareds with negative 1s, I was able to say 25 plus 4 is 29, and 15 minus 2 was 13. They did split that up as two different fractions, the 13 over 29 plus the 11 over 29i, but they could have just as easily left the answer in that form. Here we have 1 minus I cubed. There is another way of doing this called the binomial expansion, but I think especially for a smaller exponent like this, you guys would be just as well off by foiling this out. So 1 minus I cubed means writing 1 minus I 3 times, and then foiling, combining like terms, and then foiling again. Now, don't forget that that I squared is equal to negative 1, so I was taking advantage of that here to cancel out the plus 1 and the minus 1, which meant that I just had negative 2i times, and then I just multiplied the last 1 minus I through. So negative 2i times 1, negative 2i times negative I. Again, I replaced that I squared with negative 1 again, so I ended up with negative 2i minus 2. That answer wasn't listed by the county, so I assume that was some kind of a mistake in their solution. But this is the correct answer that you would want. Here we've been given a table to evaluate the limit. So if I'm finding the limit from the left-hand side, so as I get closer and closer to 2 from the left-hand side, it looks like the y value is getting closer and closer to 8. And then from the right-hand side, like the 2.1, 2.001, again, it looks like it's getting closer and closer to 8. So since I'm getting the same number from both sides, the limit is 8. If I had gotten different numbers approaching from the left and the right-hand side of 2, then I would have said the limit does not exist. This one's specified to use substitution, but honestly, that's always the first way I approach evaluating limits anyways. So I always try to just plug the number in directly, because sometimes that is going to be the same answer anyways, and that's the easiest way to compute it in most situations. So by plugging in x is 2, you get 2 cubed plus 2 times 2 squared minus 6 times 2 plus 1. Just multiply out and add combine all the like terms there to get the answer of 5. Now on number 21, you can't plug in the 0 right away because you would end up with 6 times 0 on the bottom, which is an undefined fraction. So instead, always look for any factoring and canceling you can do first. On the top, I see a GCF that we can take x out, which means we can cancel the x's on the top and the bottom. Now you can plug the 0 in because there's no longer an x on the bottom of the fraction. So once you cancel out those, now you're getting 0 squared plus 14 times 0 minus 6 all over 6. Most of this stuff cancels, so your final answer is negative 6 over 6, which equals negative 1. Well, if we plug in 2 on this case, so 2 minus 4 is negative 2, and the square root of a negative number, that's where we get i's for our answers. So don't leave it as square root of negative 2. That's never the form we want to leave our answer in. So this would be I root 2. Now, if they specify they only want a real number for an answer, then you would say the limit does not exist. But if they either don't specify that, or if they do say that they want complex numbers, that's where the I root 2 will come in. This one didn't clearly indicate whether they wanted real only or imaginary, so I'm marking what's technically the answer. Here's another one. We're plugging in negative 2 right away. It causes a problem because you end up with 0 in the bottom of a fraction. However, if you do some factoring on top and bottom, so in this case we were able to factor the numerator, that made the x plus 2's cancel. So now with what's left, there's no problem with plugging in negative 2. So negative 2 plus 4 ends up equaling positive 2 after we factor and cancel. This question is saying to find the limit as x approaches 2 from the left. So remember, if they put a minus after the number, that means the left-hand side only. So the vertical line for x equals 2 is here. My graph is touching that vertical line on the left-hand side at a height of 2. If they had said the limit as x approaches 2 from the right, then my answer would have been just above 3. It looks like 3.2 or something. But on the left-hand side, the answer was just 2. This function has asked us to find the limit as x approaches 0 from the left, the right, and then combined. So here's x equals 0. On the left-hand side, I see the graph touching my vertical line at a height of 1. So the left-hand side limit is 1. The right-hand side limit, here's the graph touching my vertical line on the right-hand side. So that one's at a height of 2. When those numbers do not match, the limit from the left and the right, then if they just said what's the limit at 0, since it doesn't match, we say does not exist, or DNE is the common abbreviation for that. And that's all for the review assignment. I hope that will be helpful in your studies for the exam.